you must have heard about Git. And maybe even you searched, what is Git? And then you found out that Git is a version control system. And you're like, okay, cool, but what does that actually mean? Some of you might even know 3 or 4 commands already. Maybe you followed a tutorial, typed the commands, and somehow made it work. But here's the thing, knowing how to do something is not the same as understanding it. If you actually want to understand Git instead of cramming commands into your brain, we need to go a little deeper. So, before we start talking about commands, branches, merges, pull requests, and all the scary looking stuff, what exactly is Git? And most importantly, why do we need it? Okay, imagine you and your friend Sally are playing the exact same game. You're playing on one console and Sally is playing on another. You get to level 5. Sally gets to level 3. Now, imagine the game only knows how to save one version of your progress, and it decides, obviously, level 5 is higher and better. I'll just save that one. Sounds reasonable, right? Except Sally's progress is now completely gone. She can't go back and play from level 3. And what if you actually wanted to go back to level 3 yourself and try a completely different thing? Well, good luck. That's not a very good way to save your progress. And this is basically the kind of problem developers deal with when they're constantly changing a project. So, what does version even mean? When people say version in version control, they basically mean a particular state of your project at a particular point of time. You have your project today, you change something, then you change something else, then you fix a bug, and then you add a feature. Those are all different states of your project. And wouldn't it be nice if you could say, hey, this version was working perfectly. I want to remember this one. That's where Git comes in. Git is a tool that keeps track of the history of your project. And one of the easiest ways to think about it is Git gives your project checkpoints, just like in a game. You reach a checkpoint, you save your progress, then you continue playing, and maybe you take a completely terrible path. So you regret, oh my god, you just want to go back to that checkpoint and try the other path. That's basically what we're doing with Git. Except, instead of saving your game, we are saving important states of our codes. And in Git, these checkpoints are called commits. So imagine you're building a website. You finish the home page. Everything works perfect. You're happy with it. Nothing is crashing now. You make a commit. That's basically you telling Git, hey, remember this state? This state is good. Everything's working. And then you build the login page. Everything works again. You hit another commit. Now, you add something else because you just wanted to try something new. You add another commit. Now you have a history of meaningful checkpoints. And if you break something later, you have somewhere to look back to. Okay, now that you know what a commit is, let's actually see how it could possibly save us. Imagine you just finished your project and everything is working beautifully. You make a commit, and then you get excited. You start changing things. You experiment. You add something, and you think that's gonna be amazing. But everything breaks instead. We've all been there. But because you made that earlier commit, you did not completely lose your working version. Because congratulations, you have a checkpoint. You can look at what changed. You can compare your current project with that earlier state. And depending on what you're trying to do, you can return to that earlier version. So Git is not just another technical tool you have to learn. It's basically a safety net so that you don't lose your work. And honestly, I learned this the most annoying way. I once worked on something for a while without making useful commits, and then I broke it. And I was sitting there like, okay, what did I just do?
Seriously?
I didn't have any good checkpoint to go back to because I was not committing at all. So now I think about commits in a way where the future me that happens to break something will thank me for making this commit. But saying this, you don't necessarily need to commit after every tiny change. Just commit after something works. Okay, now let's bring Sally back. Sally is working on the same project as you are, but she's on her computer. You are on yours. How is that supposed to work? How are you guys gonna work together? Are you going to send each other the entire project every 5 minutes through text or Gmail? Hey Sally, here's the folder. Wait, send it back. No, that would get ridiculous very quickly. And this is why Git is useful. This is another reason to why Git is useful. When you use Git in your computer, your project can have a local repository. You can think of it like a place where Git keeps track of your project's history. So you're working on your computer, you make changes, you create commits, and Git keeps track of those commits in your local repository. That's happening locally on your computer. But what if you want that project somewhere online? That's where a remote repository comes in. A remote repository is basically another copy of the repository that's hosted somewhere else. And this is where something like GitHub becomes useful. Git and GitHub are not the same thing. Well, now, when you have a remote repository on GitHub, you can push your commits from your local repository to your remote repository, and your friend Sally can get those changes as well. Now, Sally can work on her own changes. Maybe she wants to add a feature. She can make her own commits, and then she can send you a pull request. Basically, pull request is Sally saying, look, I made these changes. If everything looks good, let's add them to our project. And you can review these changes before they're added to the main projects. That's one of the ways Git and GitHub make collaboration much easier. Instead of passing random folders like final.zip, final.zip, final, I promise.zip. Final number 2, I promise, I swear on God.zip. So, putting everything together, you have your project on your computer. That's your local repository. You make changes, you create commits, which act like checkpoints. Git creates a history. Git keeps track of that history. Then you can connect your local repository to your remote repository. You can push their commits there. And if you're working with other people, they can contribute their changes too. Platforms like GitHub gives you tools for collaboration, including things like pull request. So, if you have to remember only a few things from this video, remember these. Git keeps track of your project's history. Commits are like checkpoint flags. A local repository is a Git repository on your computer, and remote repository is a repository that's hosted online. And don't worry, you don't need to understand and cram every Git command right now. You don't need to know what rebase means. You don't need to worry about head. And please, don't let Git documentation scare you away. We're gonna get there, one concept at a time. So now you know what Git is and why we need it. And next question is probably something else. And we'll see that on our next video.